Now that you've had some review of solving systems of equations in 2 variables, we want to start looking at solving systems of equations in 3 variables. So very similar to 2 variables, we're going to look at solving for a point in space. The difference is now we're going to be solving for a point in the 3-dimensional space as opposed to an xy coordinate plane. So before we get into the solving process, we want to look kind of at what does that mean? What am I solving for? What does it mean to have a point in 3-dimensional space? And then also, what does it mean to have an equation in a 3-dimensional space? So first thing we have to be able to do is we have to be able to create a 3-dimensional space. So in 3D, we're going to have our xy axis, but it's going to shift a little bit because we're also going to need a z-axis. So our x-axis, instead of running horizontally, is going to run forward and backward. It is very hard to show that in a video and on a 2-dimensional piece of paper. I'm going to do my best here, but I will have a 3-dimensional model in class that I strongly encourage you to look at to try to help you understand it more. So I can take the normal XY plane that I have here and change it by saying I'm going to have something coming out at me. So to show something coming out at me, I'm going to draw a line like this. That is going to become my x-axis now. So that is that coming towards me. Like I said, look at the model in class. This will then become my y-axis, moving left and right, and then my z-axis becomes the up or down direction. So when we plot points, we're going to talk about, do I go forward or backward? Do I go left or right? And then do I go up or down? So if I look at each of these points, if I look at letter A, so I'll try to do a different color for each one. So letter A, number 1, or the first coordinate, tells me how far to go forward or backward. So this tells me to go forward 1. It tells me to then go right 3, and then go up 2. So I'll start at my origin, and I will go forward 1, right 3, and then I will go up 2 and put a point there. I'm going to label that as point A. I'm going to do the same thing with point B. So now because my first coordinate is negative, I'm going to go back 2, then go again because my second coordinate is negative, I'll go left 1, and then up 3. So I'll go back 2, I always start at the origin, I'll go left 1, then I'll go up 3, and then I will put my point. And I'm going to label that point B. Looking at letter C, this tells me to go forward or backwards 0. So I'm going to stay at the origin, and then I'm going to go left 4 and down 2. So starting at the origin, I'll go left 4 and down 2 and put my point there. That's going to be my C. I would encourage you to pause, try D, check to see how you did. Pause, try E, check to see how you did. So D tells me to go back 1, right 1, and then up 3. So starting at my origin, I go back 1, right 1, and then up 1, 2, 3. And then I plot my point, and I'm going to go ahead and label it as C. Oh, sorry, D. And looking at letter E, I'm going to go forward 3, left 5, and up 2. So forward 3, left 5, I'm off my graph, but that's okay, I can adjust, up 2. I think I'm somewhere about right here. And then that's going to be my E. So the big thing to remember when you plot a point is forward or backward on my x-axis, left or right on my y-axis, which is contrary to what we normally do, and up or down on my z-axis. And again, check that model out at school. And then the other thing we need to do is, besides graph points, we need to be able to graph equations. So when we graph equations in 3 dimension, we want to find all of our x, or we want to find all of our intercepts, the x, the y, and the z, and then we create a graph that's going to be a plane. So in 2-dimension, we want to be y equals mx plus b and plot a line. In 3-dimension, we want to plot a plane. So how do I find x, y, and z intercepts in 3-dimension? Same way as 2-dimension. So if I want to find x-intercept, I'm going to let y equal 0 and z equals 0 and solve for x. If I want to find a y-intercept, I'm going to let x equals 0 and z equals 0 and solve for y. If I want to find a z-intercept, I'm going to let x equals 0 and y equals 0 and solve for z. So let's look at how that works. So if I want to graph this equation here, first thing I'll do is I'll find my x-intercept. So I'm going to rewrite my equation, but notice I'm going to put a 0 in for y and a 0 in for z. So I'll have negative 3x minus 2 times 0 plus 0 equals 6. Well, everything drops away except for the minus 3x equals 6. I divide both sides by negative 3, and I get x equals negative 2. So what point is that? Well, the point is negative 2, 0, 0, because the only reason I was able to get an x value of negative 2 is because I plugged 0 in for y and 0 in for z. I'm going to do the same thing now to find my y-intercept. So to find my y-intercept, I'm going to plug in 0 for x and 0 for z. So I will have negative 3 times 0 minus 2y plus 0 equals 6. Everything drops away except for the negative 2y. I divide both sides by negative 2, and I get y equals negative 3. So what does that mean? That means that I have the point 0, negative 3, 0. Because when I plugged 0 in for x and y, for x and z, I got a y value of negative 3. And then finally, doing the same thing for my z-intercept. For my z-intercept, I'm going to rewrite my equation with 0 in for x and 0 in for y, giving me negative 3 times 0 minus 2 times 0 plus z equals 6. Everything drops away except for z equals 6. What does that mean? That means when I plugged 0 in for x and y, I got a z-intercept of 6. So in order to graph it, the first thing I'm going to do is turn my regular xy plane into a 3-dimensional plane. So I will draw in my x-axis. And then that's my new x-axis, my y-axis, now my horizontal, and my z-axis is my vertical. And now I'm going to plot each of my points. So I see that my x-axis, I'm going to go back 2. So I'm going to go back 1, 2, and plot my point. And I don't go left or right at all. Doing the same thing for my y-intercept, I'm going to go back, I'm going to go forward or back 0. I'm going to go left 3, and I'm going to go up or down 0. So left 1, 2, 3, and I'll put my point there. And then finally doing my z-axis, I'm going to go forward 0, left or right 0, and up 6. So 1, 2, 3, 4, 5, 6, and I'm going to put my point there. And now I'm just going to connect them just like I would connect my y-intercept to my next point found by my slope in 2-dimension. I'm going to connect, or in 2-dimension, my x and y-intercept. I'll connect all my intercepts, and this plane here is going to be my solution to graphing this 3-dimensional equation. So to summarize, to graph an equation in 3-dimension, I want to find my x, y, and z intercepts by plugging 0 in for the variable I'm not trying to find the intercept for, plot each of the intercepts, and then connect them to show that I do find a plane.